Hi, Don.
Hey, Bob.
How you doing?
Pretty good. How about yourself?
I can't complain. Let me introduce us. I'm Robert Wright. This is the Wright Show. You are Donald Hoffman at University of California at Irvine. You're a cognitive scientist, and you've written books with titles like Visual Intelligence about the process of perception and seeing reality. What we're going to talk about today is kind of at the intersection of cognitive science and philosophy.
Hmm.
We're going to talk about the mind-body problem, the question of what consciousness is, and a question that's raised by your particular theory of consciousness, which is, so far as I know, quite distinctive, unlike anything I've heard before.
Okay.
And that question is whether what we think we see is really real or how close to real it is. Your
Right.
theory of consciousness, which is has been getting attention among the people who think about these things. Your theory suggests that things are not as real as we think they are. This bottle of water, it's useful for me to think I see it, but it may not be bear a very close correspondence to the underlying reality, right?
Correct. It's real as an experience, but it may not exist apart from my experience in that form.
Right. Now, your theory builds on the following, I think, fact about natural selection. I don't think this is really disputed, which is to say that, strictly speaking, natural selection doesn't build a brain that sees the truth. I mean, that's not what the criterion of natural selection is. The criterion is natural selection will preserve traits that are conducive to the proliferation of genes. And so it will build brains
Yes.
that have the kinds of perceptions and thoughts that are conducive to the proliferation of genes. And if those perceptions and thoughts are false, but still are conducive to the proliferation of genes, then there will be false perceptions. I think that's actually
Right.
uncontroversial, right?
Absolutely.
In evolutionary biology, and some kind of mundane reflections of that are well known. So, for example, if you imagine a species that grows up amid poisonous snakes, um, it would probably make sense when you're walking through the brush and there's anything that makes the kind of noise a snake makes. It probably makes sense to like get alarmed and even think you see a snake, even if 9 times out of 10 there is no snake. That still is on balance a healthy policy, and so that will lead to the actual illusion of snakes. You know, you'll
Yes.
sometimes think you see a snake when it's just a lizard or something else. But natural selection favors that kind of perceptual bias because it helps you stay alive long enough to get your genes in the next generation. Now, that's a mundane
Right.
reflection of this, and so too are a lot of famous optical illusions. Those are also reflections of this in ways I don't think we need to get into. But you're taking this kind of fact about natural selection and making a much deeper claim about its implications
Yes.
for perception, right? Do you want to talk about that a little?
That's right. So the standard view in the field, I think, is the one that you just described. That of course, natural selection is in the first instance only about um, propagating the genes, propagating the species, and perceptions that do that are the ones that will survive. And I think nobody argues with that. But the assumption in the field has been that the perceptual strategies that will actually be favored by that kind of natural selection are perceptual strategies that see reality as it is. Not exhaustively. No one, very, very few people would claim that we see all of reality as it is.
Mm-hmm.
But that those aspects of the world that we do see accurately. And we see the ones that we need to survive and reproduce. And so the assumption has been that, therefore, that veridical perceptions that are accurate to the state of the world, not exhaustively, but about those parts of the world that we need to know about, veridical perceptions are the ones that are favored by natural selection. That's the textbook assumption. It's the assumption by most researchers in the field. But it's an assumption that we don't have to just wave our hands about. We can actually go and check it, because evolution is a mathematically precise theory. We have the tools of evolutionary game theory, evolutionary graph theory, and even genetic algorithms, where we can actually go and ask, what does the mathematical theory of evolution do? What does it do to vertical perception? Does it favor them? Does it make them proliferate? Or does it drive them to extinction?
So can I just get clear on the terminology? In the example I gave, if it's a veridical perception in your terms, that would mean the snake is actually there. Veridical means accurately representing reality, right?
Exactly. And most people in the field of perceptual science would say that there is a real three-dimensional world with real physical objects like snakes in it.
Right.
And when you see a snake, when you have the perceptual experience that you describe as a snake, that perceptual experience is a veridical representation of a true snake in objective reality that would exist whether or not you perceive it.
As a rule. Now, it is conventionally acknowledged that there are the exceptions, like where you think, oh, that's a snake, when there's not, because you err on the side of caution, and a few other examples like that. But and maybe this is a good distinction to make. I mean, people agree that it will give rise, that natural selection will create brains that give rise to the illusion of a snake in certain cases, but that often when you see a snake, the snake is really there. And what you're saying is, no, the snake is not necessarily ever there in a sense.
That's right. So you're right that the standard assumption is that our perceptions are vertical under normal circumstances.
Right. Most
of course,
of the time.
if you get someone in a psychologist lab, all bets are off.
Right.
And there are rare circumstances where our perceptions will fail to be veridical. But the standard assumption is that under normal circumstances, we will see those aspects of reality accurately that we need to see accurately. And that was the assumption that I decided to test. And initially, I was skeptical about it because I thought, well, reality is pretty complicated. And there are all sorts of selection pressures to do things fast and cheap. And so maybe perceptual systems may not go after the vertical perceptions of the world simply because they're very expensive. And so that was my assumption going into it, that might be the interesting result. But it turned out that that's true, that we try to do things faster and cheaper because every calorie you spend on perception is a calorie that you have to get somehow. You have to go out and kill something and eat it to get that calorie. And so other things being equal, we try to do things on the cheap and do them quickly. And that certainly turned out to be true in the the Monte Carlo simulations that we ran of evolutionary game theory. But the deeper result that in retrospect I should have seen up front, but I didn't, was that fitness functions, which are the the bread and butter of evolution, they're how you get your fitness points from your actions. Fitness functions are a function of the real state of the world, whatever that world might be, but they're not identical to the world. They're functions on the world. And the key idea is that fitness functions, and we can say we can talk in detail about what fitness functions are.
I don't think we probably need to. I mean, let me make sure I understand. I mean, basically, I think you can do computer simulations of evolution, and you did computer simulations, which I gather showed what we just said, that when there's a difference between seeing things truly and seeing things that will get your genes into the next generation, whether or not they're really there, the perceptions that will evolve are those that get your genes into the next generation, right?
Absolutely.
And I guess we needn't spend much time on this, but I have a kind of a question about that, which is, it's almost like why you bother doing the simulation, since it's almost true it's really true by definition that if natural selection has to choose between a true perception and a perception that gets genes in the next generation, the latter will be the perception that transpires, right? So it seems to me you could have just asserted that as an axiom that's true by definition, and then gotten on with your philosophy, which we'll get on with shortly. But am I missing something as to why you actually needed to do the simulations?
Pretty much the reason I did the simulations because everybody else in the field, in the field of perceptual science, actually stated in print pretty much that vertical perceptions were the ones that were more fit. So they understood that it's all about fitness, but then they conflated fitness with vertical perceptions. They said that if that the reasons our perceptions are useful evolutionarily is because they're true.
Okay.
And it was that identification of the evolutionary usefulness of our perceptions with them being true that I wanted to test, because everybody was making that assumption.
Okay.
And there is the fact that although fitness does depend on the state of the world, it's not the same thing as the state of the world.
So
and so whenever the two diverge.
Sounds like you needed to convince some people who perhaps were not sufficiently steeped in the logic of natural selection, and so you did a computer simulation. But in any event, let's accept the let's definitely stipulate the premise that non-veridical perceptions will prevail in natural selection if that's what gets genes into the next generation. And let's do what you do with that, which is to take it to a much kind of deeper level than I had seen it taken. And maybe you could explain to us your kind of desktop computer metaphor for what the relationship is between what we think is reality and actual reality.
Okay, very good. So the first thing I should say is that I'm not a so-called metaphysical solipsist, which is a person who claims that there's nothing that exists except for me and my perceptions. So I'm not a solipsist of that variety. I think that there is some kind of objective reality, and it'll exist whether or not I exist. And I have life insurance, so I'm putting my money where my mouth is. But the question is, if evolution has not shaped our perceptions to resemble that objective reality, it's just given us a set of symbols that are species-specific guides to keep us alive, then how should we understand the nature of those perceptions? Most people in perceptual psychology assume that what we're seeing just is the surface of objective reality in some sense. And evolution is very, very clear that that's not the case. So how should we think of our perceptions? And so the metaphor that I think is very, very helpful is the metaphor of the desktop interface on your computer. And suppose you have on your desktop an icon that's, say, blue and rectangular, and in the lower right-hand corner of the screen, and it's for, say, an email message you're creating or a paper you're writing. You can ask yourself, if that icon is blue and rectangular, does that mean that the email message itself or the file that you're writing is blue and rectangular? And the answer is, of course not. That's silly. Anybody who thought that the color of the icons on the desktop or their shapes or their position in some sense was meant to reflect the true colors and true shapes and positions of the file in the computer, that just misunderstands the whole point of the interface. The interface is there not to show you the complex reality of the computer, like the diodes and resistors and the voltages and magnetic fields. It's not there to show you that. In fact, it's there to hide that. We pay good money for the interface software because we don't want to know that stuff. It's irrelevant to what we really want to do, like sending emails and editing photos and so forth.
Because it's for practical purposes a more efficient description of reality. To
Absolutely.
see an icon is a more useful perception than to see a bunch of electrons bumping into each other on a circuit board or whatever.
Absolutely.
The underlying reality is, and as we've said, natural selection will favor perceptions that are efficient in the sense of getting genes into the next generation most efficiently.
Exactly. So the idea then is that natural selection has endowed us with a species-specific user interface. Our space and time, the three dimensions of space as we perceive them, are the desktop, and physical objects are the icons.
Okay, so it isn't just objects that are in some sense not real. You're saying space-time is itself just a convenient projection. Now, you said species-specific. Wouldn't it? I would think that kind of all the species we're familiar with would find they don't think about a space-time continuum, but I would imagine that certainly dogs are seeing three dimensions and are in some sense implicitly assuming that some things come after others. I mean, is it species specific, the projection of space-time, or is it just more like specific to life?
Well, there may be some aspects of the user interface that is common across some species.
Mm-hmm.
But I would imagine that E. coli, for example, doesn't have very much of a 3D representation of space, perhaps. I mean, it certainly is plausible to me that it might not. If it did, I would be interested to find out that it did, but it's certainly at least reasonable to me to think that it doesn't. And so I don't want to take any aspect of the human perceptual system, the human species-specific interface, as necessarily true of any other species. I think we need to look case by case and see what evidence we might have that the interfaces of other species are like our own.
Okay.
Even within Homo sapiens, I mean, there are mutations, and it's not at all clear that your interface is exactly the same as mine. I would think that they're relevantly similar,
Mm-hmm.
and that's why we can communicate pretty well. But evolution is continuing, and so your interface is probably a little bit different from mine. So even when I speak about a species-specific interface, I'm being a little bit loose there because your interface is not exactly the same as mine.
Mm-hmm. So let me try to pursue a kind of a computer-like analogy a little. It's a little bit like, well, I guess the question is, the question that will naturally occur to people is, well, what is the real world like then? And what is the real world? You do refer to a world, and I'd be tempted to say on the basis of your metaphor that, okay, reality is as different from what we perceive as a bunch of electrons bumping into each other on a circuit board and moving in certain patterns are different from file folders on our computer. But I actually think your theory is a little weirder than that, in a sense. When I've heard you describe what you think the world is, it's not as straightforward an extension of that analogy as I might have hoped. You know what I mean?
Right.
And I would assume that at this point, a lot of people start having trouble wrapping their minds around things. Do you want to talk a little about, like, if I ask you the question, okay, what is reality like? I mean, if the analogy, in a certain sense, is kind of like I'm a creature in a video game like Pac-Man or some newer video game running around the screen, seeming to see things and responding to obstacles by moving around them, but in fact those obstacles are illusory, they're just pixels, and really the action is being governed by these electrons on the circuit board. I mean, it's my temptation to think of it that way, but I actually think things, in your view, are weirder than that, right?
That's right. So the starting point is the recognition that the very language of our perceptions of space and time and physical objects with matter and shapes and colors and so forth, that very language has been shaped by natural selection simply to keep us alive, not to tell us anything about the nature of objective reality as it is. Mm-hmm. And so there's no reason to believe that any of that language, any of the predicates of that language, and anything that could be described in that language is going to be the nature of the objective world. And that's pretty strong. What that means is that whatever objective reality is, the chances that thinking about it in terms of space and time and matter and physical objects and colors and shapes is just the wrong language. You'll get nowhere. The analogy would be, suppose I said, I would like you to tell me a detailed theory of the inner workings of a computer, but the only language I'm going to let you use is the language of the pixels on your desktop. Mm-hmm. So you have positions and colors of pixels. That's your language. Go for it. Try as best you can to describe how a computer works. Good luck. I've made it impossible for you because I've given you a language that's not the right language to do the job. Mm-hmm. And so that's the same problem that we have when we start trying to think of using the language of space and time and position, momentum, spin, shape, mass, and matter to describe the objective reality. We've given ourselves an impossible task, just like asking ourselves to describe a computer just based on the pixels on the desktop. So what we have to do is to be willing to let go altogether of some very deeply held beliefs, that there's any resemblance whatsoever between the nature of our perceptions and even the language of our perceptions and the nature of objective reality. That's a very, very difficult position for us to take. We seem to be very, very wedded to the idea that our perceptions are giving us some kind of insight into the nature of reality. At least the language of our perceptions is the right language to describe reality. And that's what I'm saying we need to call into question. Mm-hmm. Now,
And by the way, one of the things you're calling into question, I'm not sure if you mentioned this in your list, but is causality itself. So
absolutely.
If you see billiard balls bumping into each other on a computer and it looks like the ball is causing the other ball to move, well, you know that's not really happening on your computer screen. There's not causality happening on the screen. Rather,
right.
They're both just behaving in accordance with the script. You're saying the causality we think and this has been suggested by philosophers like Hume and so on, that we can't really confidently infer actual causality. We never really know more than that certain things regularly precede other certain things and so on. We never know for sure that causality per se happens. Anyway, that's another weird thing about your theory.
That's right. So I don't necessarily need to give up the notion of causality of some kind of entities. But so I'm happy to contemplate the idea that the notion of causality itself is not a fiction, but that the specific causality that we all know and love, namely that a physical object like a billiard ball hitting another billiard ball and making it move, that's genuine causality. That I think we will have to give up. So when the 8-ball the white ball hits the 8-ball mm-hmm. into the corner pocket, we can say that the cue ball caused the 8-ball to move. And for practical purposes, that's fine. It's a useful fiction, but strictly speaking, it's a fiction. There is perhaps some causal sequence going on in the objective world, and all I can do as a humble member of the species Homo sapiens is to represent it in terms of a cue ball hitting an 8-ball mm-hmm. and having a fiction of a causal interaction between those two.
And by the way, in some scenarios where causality is an illusion, people are actually talking about a completely deterministic universe. So what they're really doing is just watching a movie and everything has been prescribed from the beginning. And the idea of like causality is false. Yours is not necessarily, as I understand it, a completely determined universe. At least you use terms like choice in your theory, which we'll get into
yes.
a little, right? So you're not talking about a deterministic universe necessarily.
Not necessarily a deterministic universe.
Okay.
And I should point out that that the theory that I'm working here has two separate aspects, and that one could buy the one and not the other. So the first aspect that I'm fairly confident about is that evolution entails that we almost surely do not see reality as it is. Mm-hmm. That I'm pretty confident. If you buy evolution, then I think that you have to buy the conclusion that space and time and physical objects are a species-specific desktop and not a depiction of reality. Now, once you've bought that, there's, we have to give up our dearly loved theory that reality resembles what we perceive, and that's hard to give up. But so that I think just follows from evolution. The next step is to ask, what theory of reality shall we propose? And there's an infinite number of possibilities, right? We've thrown away one theory, the one that we happen to like a lot, but it's just one out of an infinite number of possibilities. Mm-hmm. So when I go and propose a specific new theory, I'm probably wrong. There's a lot of options out there. So that's going to be a far more, problematic direction in terms of, how confident I am. So I do have a theory, and I can discuss the theory with you, but I should point out that theory is separate from the evolutionary conclusion.
Okay.
The evolutionary conclusion is we don't see reality as it is. The second step is, okay, now as scientific theorists, what shall we propose as a new theory of that reality? Mm-hmm. And so someone can buy my first, proposal that we don't see reality as it is, and not buy my proposal about the nature of reality that I'm going to propose.
And the proposal you have, there's an actual mathematical version of it.
Yes.
I think it has maybe 7 variables or something like that. And we won't be able to get into that in any depth at all. But one interesting feature of it is I think you claim it's testable.
Right.
And so we'll talk about that. Now, before we get into that, I want to get a little more deeply into the question of, okay, if this is not the real world, what is the real world that this is a kind of, in a certain sense, a reflection of, or bears a certain kind of correspondence to? And here's where things get weirder, as if things weren't weird enough. At least by my reckoning, as I understand it, the world, is it that it's kind of co-created by conscious agents, or I mean, you tell me. You refer in your theory to conscious agents, and I'm not sure if you does a conscious agent correspond to what we would think of as a conscious, like I'm a conscious agent, you're a conscious agent, like, so right now we are two conscious agents interacting. Is that the correct terminology in your theory?
Yes, to a first, there's a first step, yes, but there's more to it.
Okay.
And so I'll unpack it just a little bit. So here's the motivation for the direction I've gone. The idea is, it may be the case that all of my beliefs are false. I may know nothing, and that's a serious possibility. There's, as scientists, we have to acknowledge that possibility.
Mm-hmm.
But if there is anything that I believe that's true, it's that I do have conscious experiences. I mean, if my belief that I'm, feeling a pain or smelling a rose or tasting chocolate, if my belief that I'm having an experience is wrong, then I'm pretty much wrong about everything, and we might as well just eat, drink, and be merry, because it's, there's really nothing else that we can do as scientists.
Yeah, this is a little like what Descartes said. The minimalist assumption is that you are having this experience whether or not the experience is true.
That's right. I don't want to therefore go to the cogito ergo sum kind of thing. I don't want to perhaps go where he goes in terms of trying to prove my own existence, but just merely that if I'm wrong that there are experiences, then pretty much there's not anything secure that I can go with. So I decided to say, okay, let's go with that. Let's if space and time and matter, which are just the format of my perceptual system, is not the right predicates to describe reality, and I can't let go of the idea that I have conscious experiences, let's just start with consciousness. Let's see if we can get a mathematical theory of consciousness and conscious experiences, but a new kind of theory. I mean, there are many cognitive neuroscientists and philosophers who are trying to get a theory of consciousness, but the typical approach is to say, let's start with brain activity and say that this kind of brain activity or this pattern of brain activity is consciousness or gives rise to consciousness. So consciousness is secondary to some physical description of the brain or microtubules in the brain or reentrant thalamal cortical loops in the brain or something like that. And I'm saying, let's not start with our interface of space and time. Let's start with the description of consciousness on its own terms. So what do we mean by consciousness? Not as, inhabiting space and time, because we don't know that it inhabits in space and time. We just want its own properties on its own. And so the idea is that there are conscious experiences and there are actions that you can take based on those conscious experiences, where the you is used in a more generic sense, not you as a person, but consciousness itself. And then there is some kind of notion of a choice of the action that you're going to take based on your conscious experiences. And then those actions have an effect on the objective reality, whatever it is, and that objective reality in turn affects your conscious experiences. And those are the key ingredients that I put together into a very, very simple mathematical formalism.
And those things, you kind of have to stick with those premises if you're going to remain within the framework of natural selection, which is the basis of your whole theory anyway. I mean, there have to be these discrete entities, which we call organisms. That's what they look like to us, whatever they may be at the deepest level. These discrete things that act on the world based on their experiences. And so you're sticking with that at an abstract level, those premises of natural selection. But beyond that lies the weirdness. So go ahead.
Yeah, I absolutely agree with what you're saying, and it is actually in accord with what Dawkins and Dennett have called universal Darwinism, the key algorithmic principles underlying Darwinian evolution of replication, retention, and selection. And
variation at some point.
I'm sorry, variation. That's right. So the So the idea was, and that's what evolutionary game theory is based on, is that it's essentially a mathematical representation of universal Darwinism.
Mm-hmm.
But what it does allow you to do is to think about biological evolution without some of the physicalist assumptions that are usually made as well. So that organisms are real physical objects in 3D space, and DNA is a physical thing that exists in space and time. We don't need to have those assumptions. And in fact, what evolutionary game theory suggests is that those assumptions are actually false. So that we have to rethink Darwinian evolution, based on evolutionary game theory itself. But you're right that the theory of conscious agents does still keep the core of Darwinian evolution in terms of the universal Darwinism aspect of it. Mm-hmm. Absolutely.
Okay, and there is this idea of discrete conscious entities or discrete packages of consciousness. That has to be preserved too, right? I mean,
yes.
Consciousness can't just be this undifferentiated universal mass. There have to be discrete incarnations. You know what I mean, right? Well, your theory calls for there to be more than one conscious agent.
Absolutely. And in fact, perhaps an infinite lattice of them, from the very, very simple to the very, very complex. And it turns out the formalism, so it allows for conscious agents. There's a formal definition of conscious agent, so anything that satisfies that definition is a conscious agent, according to the theory. And they can go all the way from the simplest ones, which have only one bit of experience, literally, essentially one bit of possible experiences and one bit of possible actions, all the way up to, a countable infinity of
So the first case is strictly hypothetical. It's not like you think that there is some organism out there that has only two options in terms of consciousness, right?
Well, my theory forces me to entertain that possibility and to imagine consciousnesses that are very, very, in some sense, restricted.
I see. So consciousness may go beyond the organic world in your theory.
Well, absolutely. Yeah. Absolutely. In fact,
so what we call a proton, which of course is not anything like what we conceive it to be in your theory, but whatever it is, it could have consciousness. So this is kind of like what's called panpsychism, which is that everything in the universe is...
It's not panpsychism, but that's a very important distinction. So panpsychism, for example, with respect to electrons and protons, is the idea that electrons, in addition to their physical properties like position, momentum, and spin, and so forth, also have consciousness properties. Mm-hmm. But I'm denying that there is such a thing in objective reality as an electron with a position. Right? I'm saying that the very framework of space and time and matter and spin is the wrong framework. It's the wrong language to describe reality. So I'm in some sense more radical than panpsychism. Mm-hmm. Panpsychism is almost a dualism the way I'm formulating it. There are physical objects like electrons, and in addition to their physical properties, they have these consciousness properties. Mm-hmm. I'm saying let's go all the way. It's consciousness and only consciousness all the way down. Nope.
So, but it's not a pure idealism, as I think like Berkeley or whoever, right? It's
right.
So
for Berkeley to be is to be perceived, but the conscious agents are perceivers, and they could be without being perceived. Mm-hmm. They might be inert, but their existence is not dependent on being perceived. So it's got my view has a higher affinity with idealism than with panpsychism, but it's one difference. There's a couple differences. First, I like to call my point of view conscious realism, because I want to say that it's often been put out as realism versus idealism, and I think that's it's just the wrong way to frame the thing. I'm realist about consciousness. Others are realist about physical reality. Mm-hmm. I'm not realist about physical reality. I think that it's part of the user interface of consciousness. But I am very realist about conscious experiences and conscious choices and so forth. So I call it conscious realism, that the nature of objective reality is consciousness that can be described mathematically. Mm-hmm. Now, for me then, to solve the mind-body problem, I have to solve it in a different way than everybody else is trying to solve it. Right? Most people 99% of the researchers trying to solve the mind-body problem are starting with the physical reality, in particular, brain states, brain activity, and they have to show how consciousness might arise from that or be identical to that.
Mm-hmm.
I have to go the other direction. I start with a mathematical theory of consciousness completely independent of any notion of space, time, or matter. Completely independent. And it's my burden, then, to say that this mathematical model of consciousness can give rise to all of the modern mathematics of, say, quantum mechanics and general relativity.
Okay.
So if I cannot derive from this theory of conscious agents, first, what we already know about quantum field theory and gravity, and then hopefully a new theory of quantum gravity itself, then I'm wrong. It's just that simple.
So there can be conscious agents that not only don't correspond to electrons per se. Well, first of all, there can be conscious agents that don't correspond to any of the physical phenomena we currently describe as part of a scientific framework. Is that right? Don't
Absolutely.
correspond to protons or anything else.
Absolutely.
And it isn't just that science hasn't yet discovered the physical phenomena that would correspond to the conscious agents. You're saying that in this sense, conscious agents just are more fundamental than what we refer to as the physical world.
Absolutely. Absolutely.
So first came the conscious agents, and then came the physical world. But see, this is where I get a little caught up with the chicken and egg problem when I start putting this in terms of natural selection, right? I mean, for natural selection to happen, as we conventionally conceive of it, you've got these conscious agents. I mean, we assume that they're conscious, but anyway, we've got these agents, and then you've got this like world for them to respond to. And it's true that the world consists partly of each other. Bacteria respond partly to each other, but in the first instance, when the first self-replicating form of organic life came into being, it was responding strictly to a physical. So it's like the physical world, which we normally conceive of as unconscious, was a given, and then self-replicating things came along and started responding to it. And so in the conventional reckoning, you just have this dichotomy.
Right.
Now, I recognize that that dichotomy in a way rests on the assumption that what we refer to as the inorganic world is not conscious, and you would take issue with that assumption. But
Exactly.
still, I can't be alone in having trouble like wrapping my mind around this whole thing and kind of vaguely perceiving a kind of chicken and egg problem, right? Even
Absolutely.
you must have this problem a little, right?
Well, yes, because like everybody else, I am naturally a physicalist and a naive realist.
Mm-hmm.
I believe whenever I'm not thinking carefully, I always believe just naturally that I'm seeing reality as it is. That's just sort of the way we've evolved, and so it's very, very difficult to step outside of that when evolution itself forces me to take that idea seriously. But the idea is that when I interact with something that to me looks inanimate, like a rock, it doesn't look living to me. And so I'm not saying that the rock itself is conscious, but that the rock itself is a symbol that I'm using to represent a reality that is completely unlike a rock, a reality that is not in space and time, and a reality that is in itself a potentially infinitely complex interaction of conscious agents. But because I have
the reality itself is an interaction of conscious agents.
Yeah,
You mean including you, or not necessarily including you?
Well, I'm certainly interacting with it, so yes.
But I mean, but I mean, before you started interacting with it, I mean, you would say, I guess, if it exists in itself, then it itself has to be an interaction of conscious agents.
Exactly right. Exactly right.
And
That's the ontology I'm proposing here. There's conscious agents all the way down, and that's what exists. Even if the conscious agent that I call me didn't exist, there would be other conscious agents, and so that's what I'm interacting with. Now, because I'm a finite conscious agent, I have finite representational capabilities. This is presumably, though, an infinitely complicated universe of conscious agents. That means that almost all of it is beyond my representational capacity. My ability to represent it, I can represent only a probability zero subset of this reality. And the parts that I do represent, I mean, so when I interact with you, by looking at your expressions and your body language and so forth, I can get some idea about your conscious state, the kinds of experiences you're having, your mood and so forth. I get some insight into you as a consciousness. When I interact with my cat, maybe a little bit less. When I interact with a rat, even less. With an ant, even much less. And when I get to the point of a rock, I've essentially given up. But in terms of understanding the nature of the consciousnesses, right? But that is a limit of my representational system. And here's the problem that we always have. As humans, we tend to conflate the limits of our representational system with an insight into the nature of reality. So we mistake our limits for an insight into the nature of reality. It's like saying that the icons on my desktop only have two-dimensional positions and pixels, therefore reality can only have two dimensions and pixels and nothing else. Well, no, that's just a limit of my desktop. If I could just sort of think outside of the box, I would realize that most of the categorizations I make in the world, like between animate and inanimate, are artifacts of the limits of my perceptual system. They're artifacts of the fact that I have to give up at some point in what I can represent of the nature of reality. So when I see something that I call a rock, and then conclude that, of course, nothing conscious is going on here, what I've done is mistaken a deficit of my representational ability for an insight into the nature of reality. And that's what we tend to do all the time. So what we have to back off from is to say, look, I mean, my perceptions are the humble abilities of a particular species, and they're not that very sophisticated. And I just need to understand, I have a very, very limited species-specific set of representations that was just designed to get me through the day, not to give me an insight into reality. When I see a rock, all bets are off about what it is, about the objective reality that I'm really interacting with. And so my proposal is that, not that the rock itself is conscious, that's silly, but that I'm interacting with a complex world of conscious agents, and the best that I can come up with, because I'm a poor, weakly endowed conscious agent myself, the best I can come up with is this stupid little symbol that I call a rock. But then, because I'm so unimaginative, I assume that the rock in space and time is the final reality, and there's a big distinction between animate and inanimate. So
it is. I mean, when you think about it, it's amazing that, given the fact that our brains were really just designed by natural selection to get us to the point where we could survive in a hunter-gatherer society and navigate the social landscape and everything else, it's just kind of stunning that science has gotten as far as it has gotten. I mean, however misleading you think its representation of reality is, its predictive capabilities are reasonably impressive, and it's amazing it's gotten as far as it is. And by the same token, it would be kind of shocking if we could see like the whole picture, given given what natural selection actually designed the brains to do, which is the heart of your theory in a certain sense.
Absolutely. Now, we have to take our cognitive capacities one at a time to see what evolution does with them, right? So my simulations indicate that, and those are my graduate students. I should mention, Justin Mark, Brian Marion, and Chetan Prakash, who've been doing this work with me. Our work indicates that the probability that our perceptions have been shaped to reflect reality as it is zero. It's strictly speaking zero. But there are other cognitive capacities. For example, my ability to reason mathematically. Now, it turns out that there are circumstances where I do need to reason mathematically about fitness, not about reality as it is, but about fitness. The fitness consequences of eating what I call apples, of getting 2 apples, might be roughly twice as good as just 1 apple. Or if in a hunter-gatherer society where we're cooperating and having to share, I might need to be able to detect a cheater. You didn't contribute as much as you could have contributed. I need to be able to quantify how much you contributed, how much I contributed, and then punish you if you're cheating. So in these very limited domains, there could be selection pressures not to give us like deep insights into mathematics, but just enough mathematics, again, to survive. But that's the interesting thing. Whereas natural selection uniformly gets rid of vertical perceptions, it does not uniformly get rid of vertical math. It gives you little pockets of potential veridical math where you need it for just little things like checking for cheaters and counting apples because of the fitness consequences.
So you're suggesting then that our logical intuitions, some of our logical intuitions, bear a closer correspondence to a kind of, in some sense, real logic out there that exists than our perception of the physical world bears to a real physical world.
Exactly right. So I'm not saying that evolution has endowed all of us to be mathematical geniuses that see all the truths of mathematics. Not by a long shot. Every once in a while you have a brilliant mathematician who comes along, but most of us have just a modest endowment that was selected because we needed just a modest amount of mathematics and logic to reason about the fitness consequences of our actions.
Mm-hmm.
And so that's the interesting thing. I found it beautiful because if the evolutionary simulations had shown that natural selection systematically eradicates true logic and math, just like it eradicates true perceptions, then I would be in a position of shooting myself in the foot. That would be a self-refuting use of evolutionary theory. So I found it quite interesting that the theory of evolution does uniformly shoot down true perception, but it allows pockets in which limited amounts of logic, limited amounts of mathematics can be used for limited species-specific needs. And then those genes, here's the beauty of mutation, that every once in a while you get, a von Neumann who comes along and has just the right collection of mutations such that all of a sudden the mathematical prowess is spectacular. Again, it's finite, but it's more than most of us.
Okay. When you say that, I don't want to dwell on this, but when you say that in your simulations, veridical perceptions are completely extinguished through evolution, they are driven to extinction, true perceptions, it makes me think that I've misunderstood a little what your simulations are up to. When I asked you earlier why you bother to do the evolutionary simulations, because, it seems to me that all depends on whether you posit, whether you assume that veridical, that the real world corresponds to the perceived world. When there's a discrepancy between veridical perception and fitness-conducing perception, we know which one will win, but it seems to me you have to assume that there's a discrepancy between those two. You don't know for sure that there will be a discrepancy, right?
Well, so we're about to publish a theorem. So we have the simulations that I've published before, but we've now proven a theorem. And the theorem basically says for generically chosen worlds, and if you want, we can get into the mathematics, but
I think we'll pass, thanks.
Yeah, we'll pass, yeah. So for generically chosen worlds and generically chosen fitness functions in those worlds, an organism that sees reality as it is in that world can never be more fit than an equally complex organism that sees none of the reality in that world and is just tuned to the fitness function. And as the complexity of the world increases and as the complexity of the organisms increase, the chance that even by accident the truth-seeking organism can ever win in the evolutionary competition goes to zero.
Because the perception of reality is costly?
It is costly and it's irrelevant.
Strictly speaking, yeah.
It's completely irrelevant.
Although, well, again, we shouldn't dwell on this, but if it turns out that veridical and utility maximizing perceptions correspond, then it's not irrelevant. But
you're right. You're absolutely right about that. But that's why I was talking about generically. So for generically chosen worlds and generically chosen fitness functions, which means that what you said is strictly true, but the probability of that happening is zero. So the probability that
that's what seems to be more like an assumption than a consequence of a simulation. But maybe I'm wrong.
Well, it comes down to what I'll give you a concrete idea about why it's more than just an assumption. That it's more of a mathematical property. Suppose that I have just the real line, just a line. So I have an order that 0 is less than 1, less than 2, less than 100, right? So maybe that represents resources. 0 means no resource, no water. 100 means a lot of water, and so forth. And now I ask possible fitness functions. Maybe a fitness function might be that more water is more fit. So 0 is very, very low fitness water, and 100 is very, very high fitness water. And so that fitness function is monotonic with the amount of water. That's one kind of fitness function. Another kind of fitness function might be a Gaussian, where like an intermediate value of water, like 50, is really fit, but 100 is too much, right? You might drown. 0 is too little, you might die of thirst. And so you could have that kind of fitness function. And you can just ask yourself, what are all the possible shapes of fitness functions? And so you can look at the collection of all possible fitness functions, and then ask, out of that whole collection of fitness functions, which fitness functions happen to be monotonic with the truth, with the reality, such that if you were tuned to fitness, you would also happen to be tuned to reality. That's a clean mathematical question, and it turns out those have probability 0.
Okay.
So if you're tuned to fitness, yes, there is a probability 0 chance that you will be tuned to reality. But it is probability 0. Probability 1, you will not be tuned to reality. And that's the sense in which I say the probability is 0 that natural selection will favor a veridical perception.
Okay. I think I'm going to have to review this part of the conversation later and try to grok it. But
okay.
Let's in the time remaining, let's do a couple of things. You've got an actual theory, a theory of the. Are you going to show us the theory on the board for those of us?
I'm just going to get a little bit more light on the room here.
Oh, I see. I thought I was going to have to look at mathematical symbols. I'm relieved to hear that you're just turning up the light. So you have an actual mathematical formula, kind of about that reflects the relationship between consciousness and the world, I guess. Why don't you see if you can just put it into words, and that will be an imperfect rendering, I'm sure. And then I'd like you to discuss the sense in which you say it's testable. But for starters, why don't you just try to, without hope of complete success, give us at least the flavor of the mathematical theory, what it is trying to do.
That's right. So the mathematical theory, I'll just say first, it's in the spirit of Turing, when he came up with the Turing machine for computation. It's a very, very simple formalism, and it's 5 or 6 little mathematical components that are apparently universal. Anything that can be computed with this universal Turing machine, with a simple Turing machine. And the idea is to come up with a simple formalism as well for consciousness. And so the components of this formalism, there are, each conscious agent has a set of experiences that are possible for it. So it could be a small set, or it could be up to a countable infinity of discrete conscious experiences it could have. Based on those experiences, it can make decisions about how it wants to act. It has a collection of actions that it can take. And then, based on the action it chooses, it then can act on the world, where it doesn't know what the world is. All the agent knows is it can choose an action, and it does that action, but it doesn't know what the world is. And then the world feeds back and changes the perceptions that the agent has. And the only other part of the structure then is a discrete counter. Every time the agent gets a new percept, a new experience, this counter increments. So the agent has, so to spell it out, there's a space that I call X of experiences, a space G of actions that the agent can take, a mapping D, which is the decision. Given my experience, what action do I want to choose? There's mapping A that says, given the action, I'm going to now act on the world. So A is the action on the world. And then there's a map P from the world, which is the perception map, where the world then changes my experiences. And then there's a counter T that just is a discrete integer counter that increments every time I have an experience. That's the entire formalism. There's some mathematical details about the nature of these maps. Technically, they're Markovian kernels, and the spaces are measurable spaces. And having said that, now I've actually told you the entire mathematical structure.
Right. And it kind of, roughly speaking, seems comprehensible and makes sense, with a possible exception of the part where you realize that the world is itself conscious agents. Whereas normally we think of the world, we think of our consciousness in here, there's the world out there. And I think this is the, there's a kind of recursive quality to the theory, which is not shocking when you think about it. I mean, it's not shocking that the correct theory of consciousness might be incomprehensible when you think about it, because the problem is deep. But it's true that that's kind of in a way, the least intuitive. That's a stumbling block to ready intuitive comprehension of your theory, right? Is this kind of self-referential feature that the world is not just this world out there. It is itself conscious agents, although again, conscious agents needn't be organic beings.
No, they're anything that satisfies this mathematical definition is a conscious agent.
Mm-hmm.
And the idea is to think about objective reality as a big social network. That's the idea. It's a bunch of interacting conscious agents. And the dynamics is much like the dynamics of social networks. And the evolution of consciousness will be very much like the evolution of social networks in social network theory. And the idea is going to be that by looking at the evolution of social interactions among the conscious agents and then projecting that evolution back into the space-time interface, say, of Homo sapiens, I should get back Darwinian evolution. That's going to be a constraint on my theory of the evolution of consciousness in this big social network. So it's going to be very, very testable. If I have a theory of conscious evolution, which is going to be a graph theoretic theory, very much like we use graph theoretic analyses of interactions on the internet and so forth to understand why some websites get a lot of hits and others are less hits, who's got more influence, who's got less. All the work that's been done on social networks is going to apply here. It'll be an evolution of conscious agents, and that evolution, when projected back into a particular space-time interface of Homo sapiens, better give us back the Darwinian evolution we know and love, or the theory of conscious evolution is wrong.
Okay.
So that's going to be one way that we're going to have testable predictions.
So that's an example of the testability.
Absolutely.
So wait, does the testability lie in the more fine articulation of the formalized theory in a way that succeeds in corresponding to the dynamics of natural selection or something? Or is that
will be one of the many ways that will be tested. But I definitely will want to show how the theory of evolution of consciousness in this framework of conscious agents gives detailed understanding of why we see Darwinian evolution when we look at it through the lens of space and time. But that's not the only thing. That's not the only constraint. I will need to be able to make predictions about the dynamics of space-time, for example, at the Planck scale. If I can't do that, if I can't actually make new predictions about quantum gravity from this and understand how interactions of conscious agents can create interfaces of space-time and make new predictions about the dynamics of space-time at the Planck scale, then once again I'm wrong. And there are other predictions that come out of this that have already been tested, that sort of come out of just the evolutionary game stuff. I mean, if I'm correct, and space and time and physical objects are just the wrong language to describe reality as it is, there's a clean prediction that follows from that. And the prediction is this. And this prediction, by the way, has caused lots of comments on the internet. People just don't understand this, so I'll try to explain it. Clean prediction that a physical object like an electron has no position and no momentum and no spin at all when it's not observed. And that's a clean prediction of what I'm saying. If I'm wrong about that, then everything I'm saying is wrong.
Well, something like that had been suggested by people who all along had responded to one of the mysteries of quantum physics by saying that it is the observation of the system that forces the wave function or whatever to collapse into definite form, right? So this is a little like that, although maybe not exactly like it.
It's a bit like that, although some quantum physicists have tried to keep a physical reality. For example, Bohm tried to keep a genuine position and velocity for a particle even when it was not observed in his approach. So quantum physicists have been not completely in agreement about how to interpret the quantum formalism on this regard. But the evolutionary games forced me to take a strong position. If space and time and physical objects, position, momentum, is the wrong language to describe reality, then I'm forced to interpret the quantum formalism and my own theory to say an electron cannot have a position or momentum when it's not observed. If it does, then there's no reason to listen to me any further. I'm completely wrong. And the objection that people have to this is they say, well, how in the world can that be a testable statement? I mean, if you're not looking, if you're not observing, then how can you know what's going on? And so there's two ways to think about this. First, take the opposite statement that everybody believes, that that the electron does have a position and a spin when it's not observed, right? Or that a rock has a position when it's not observed. Everybody thinks, of course, that's a genuine scientific statement and is probably true.
But we can't verify it.
Yeah, the question would be, if it's scientific, then it has to be falsifiable. And how would you falsify it? Well, you'd have to show that it's not the case that the electron doesn't have a position when it's not observed. In other words, my hypothesis needs to be part of that whole package.
Yeah, but if you set up a video camera to record the rock when you're not there and you come back, what would you say about that evidence? Would you say that the video camera was itself conscious, or would you say that there's some kind of retrospective effect of consciousness, or what?
Well, you don't know about anything about the rock until you yourself view the video. True. So you don't know, the assumption that the video exists when you're not looking is part of that whole assumption that you're making there. So it's a far more clever experiment that has to be done to test this hypothesis. Just taking a video and then looking at the video later is not going to do it, because the question still arises, did the camera itself exist when you weren't looking? Every time I look, I see a camera and I see a video, but that doesn't mean that a camera and a video exist when I don't look, right? That doesn't logically follow. And so it turned out, by the way, very, very bright people like Pauli and others thought that this question was not a scientific question, that it was like asking how many angels dance on the head of a pin. To ask, does an electron have a position when it's not observed? But it turns out John Bell in 1962, 63, something like that, showed that this is not an angels dancing on the head of a pin kind of question. It's an empirical question. He came up with very interesting mathematics called Bell's inequalities that gives you a precise way to test the hypothesis that an electron does not have a dynamical property like spin when it's not observed. Clean. It's one of the deepest successes of the human mind is Bell's theorem. And in the years since Bell published that, there have been over a dozen very, very careful tests. And in every case, the experiments come out compatible with the interpretation that an electron has no dynamical properties when it's not observed. Now, no experiment ever forces a theoretical interpretation. I mean, that's just part of elementary philosophy of science. No data ever force a scientific theory to be, true. Right. There's always an infinite number of theories that are compatible with any data. So I'm being very, very careful when I say that all of these experiments the results are always compatible with the interpretation that an electron does not have a position or a spin when it's not observed.
Right, and in fact, probably more common interpretation of some of this stuff is that what forces the electron to assume a definite location and everything is interaction with a macroscopic physical measuring device, not observation by what we think of as a conscious being per se. That's an alternative interpretation, right?
That's been one of the interpretations that quantum physicists have tried to give. In particular, Bohr, with the Copenhagen interpretation, tried to do that. I'm taking a very, very different tack. I'm saying that electrons and any physical objects that have position and momentum and so forth are just a human species-specific representation of a reality that's utterly different. And so it's no surprise, since electrons are nothing but our symbols. it's no surprise that those symbols don't exist when we don't token them, when we don't observe. They only exist when we observe because they are the symbols that represent our observations.
Okay. So I think you've given us plenty to ponder, and I myself, I'm sure, should listen to this conversation several times and ponder it before interrogating you further. But final question.
Yes.
Has your view of the world, affected the way you live in any way?
Well, it has in a couple ways. First, it's very painful because I'm, like everybody else, a naive realist at heart. I mean, my default mode is that 3D space and objects in space-time are the reality. And it's when I put on my thinking cap that I have to recognize otherwise. But, frankly, when I go outside and look, it looks like the sun is going around the Earth. And every time I step outside, it looks that way. And I know otherwise. And so, it's painful in the same way that it was painful for us to give up a geocentric universe. I mean, people died and were burned at the stake for that. And it's sort of painful psychologically for me to give this up. And slowly my perceptions of the world are changing. But it's interesting. Evolution shaped us with symbols that we have to take very, very seriously, right? If we don't take them seriously, we'll die. And we were given the symbols that we have because they're what we need to survive. So we have to take them very, very seriously. And for some reason, we have a penchant for taking them literally. I see a snake. That symbol means there are things I should not do. I shouldn't.
Well, it's more efficient to take them literally. Just think of the time you've wasted not taking them literally. Right?
Right.
I mean, from evolution's point of view, you're better off not, wasting the time.
Yeah. Why waste the time wondering about it? You just get out of the way of the snake. Don't step off the cliff.
Right.
Step out of the way of the train. But strictly speaking, taking them seriously does not mean we have to take them literally. And so that dissociation is emotionally wrenching, and so that's affected me that way. But I guess the other effect is it's made life far more interesting. There's a lot to explore, a lot I don't know, and things that I thought I knew, I've had to give up, and so it makes life far more interesting for me as well.
Okay, well, we'll leave it there for now. I may, again, after pondering this, ask you if you have time for another conversation,
Yes.
but you've given us plenty to think about. Thanks for taking the time.
Thanks, Bob.
I encourage people to look at anything you've written on this. You're writing a book for, I think, a popular audience. It'll be a while before that's out, but help is on the way.
Yes.
And thanks so much, and good luck with it.
Thank you very much, Bob. Good to talk.
Same here.